So today, in simplifying seemingly complex algorithmic concepts into things that can be understood by the normal human brain, we're going to visualize whether or not a specified operation is a subset of the big O notation of, well, anything. Um, excuse me. So we're gonna use f of n for the left side and O of n for the right side, and we're determining if f of n is an element of O of n. Now, if we have, let's say, f of n just being n, you see we get a nice straight line, 45-degree angle. 45? Yeah, 45-degree angle, right through there from negative infinity all the way to positive infinity. And if we now plug in that O of n is n squared, you'll see that we have a nice parabola that stretches from wherever infinity that way to wherever infinity that way. You'll notice something. See that O of n crosses on top of f of n at 1, 1. And it stays that way. It will always stay on top from 1, 1 to infinity. N from 1, 1 will always be under it. We're looking at the whole up and down thing here. O of n is above f of n. So that means that since O of n stays on top from 1, 1 to infinity, infinity, that means that n is an element of O of n squared is true. Now, if we flip it and set f of n to n squared and O of n to just n, you'll notice that f of n stays on top from 1, 1 to infinity, infinity, and O of n stays on the bottom. That means that f of n is not an element of O of n. And this works for anything you throw at this. If you can visualize it like this, it makes things a whole lot easier. So if you're ever in doubt about whether or not you're right, just pull up a graph and see where or if they ever intersect, and which one stays on top for the rest of the whole, from whatever point, in this instance 1, 1 to infinity. If f of n stays on top, it's not an element of O of n, and if O of n stays on top, then f of n is an element of O of n. I don't understand why this seems so complicated when it's presented to you in text, but once you take a look at what it really is in terms of visualizing it with lines, then it kind of clicks, and it gives you an easier chance at determining whether or not f of n is an element of O of n. That's all I've got for today, and I'm not sure if I'm going to continue doing this, but it was something that helped me understand this particular problem, and I'm hoping that it helps you.